So good morning, everybody. My name is Michael Aldridge. I am a staff systems engineer at BetterHelp, and this is my journey from a colocation facility to cloud-based and dynamic with Nomad. So a little bit about me. I am the-maldridge. This is my handle across everything, and you start to see it pop up when people ask about doing weird things with Nomad and Docker. I run infrastructure at BetterHelp, so I'm responsible for things ranging from our internet-connected soda machine through to our production servers. Go is my favorite programming language, so I really enjoy working on Nomad, things in the HashiCorp stack. It's just a lot of fun. I'm also one of those annoying people who likes to ask why when somebody tells me something is standard. I want to know how it got there, and why is it actually the best choice. For the last 10 years, I've been bouncing around various projects, ranging from a planetarium built on 80s era software to I worked on Google search. Now I'm at BetterHelp. One other place you may have heard from me if you frequent the Orange site is I work on Void Linux in what little spare time I have after work. So a little about BetterHelp. BetterHelp is the world's largest online therapy company by a number of different metrics. Probably the most impressive is that we connect over 100,000 clients each month to over 8,500 different counselors. And in fact, just last week, we passed our 75 millionth online counseling session. I couldn't say it better than is already written here, but our mission is to provide easy, affordable, but most importantly, private access to professional counseling anytime, anywhere. Pretty much anywhere you can get a cell signal, we believe you should be able to talk to a counselor. So before BetterHelp moved on to have Nomad and the HashiStack, what were we running? We were hosted at a SoftLayer colocation facility in Dallas. We ran on a mix of Ubuntu and CentOS. We had a Chef server. It managed some things. And we had a lot of very interesting code that deployed our primary application stack out onto the fleet. This involved rsync, set UID helpers, shell scripts written in PHP. It was a very interesting process, something that as the company was starting to grow beyond just a single table's worth of developers, we realized needed to change. We did make use of some cloud services at the time, but largely it was based on where things happened to land during prototyping. There wasn't really a grand overall design for our use of cloud at the time. So one of the first steps to becoming a modern operations and systems world is to kind of look at how everybody else is doing it. We chose to containerize all of our applications in order to make this happen. And specifically, we settled on Docker as our containerization system of choice. We chose this primarily because we use Mac laptops for developers, and Docker is extremely well supported on the Mac. It also is extremely well supported on our Linux distribution of choice, Alpine Linux. We really wanted to make sure that applications were self-contained. We needed to be able to simulate exactly what would run in prod on a laptop and ship changes with confidence. We also needed to be able to say that there was an atomic state transition. Using our rsync deployment method, there was always some question about what happened when files were mid-copy and a request came in. Last, but perhaps most important, in a business where we deal with sensitive information, we needed to make sure that our process was easier to understand for our auditors so that they could confidently verify that we were following best practices and that we were taking good care of customer data. So obviously, my organization settled on Nomad, or I wouldn't be here speaking with you today. But it's probably a good thing to take a few steps into why we chose Nomad. There are, of course, many cluster schedulers available. So we started looking at what are our language investments. We have significant investments in PHP 7 and JavaScript. That's what our primary application stack is built in. To the best of my knowledge, nobody's yet built a cluster scheduler in PHP. And if they did, it's probably not something that's going to gain a huge amount of traction at this point in a world where we have a few major players that are already established. We had a Chef server, so we did have some investment in Ruby, but this server was much more pet than orchestrator. It required a lot of babysitting, and Chef is one of those things that works really well if you can make your problem look like something that Chef does well. Unfortunately, we were having a lot of trouble making what we wanted to do look like a Chef problem. My background is heavily in Go. It is my favorite programming language, and I use it in probably more places than it's appropriate. But that's the language I like to use. I also like to claim an allergy to Java, so that kind of ruled out several other options. So if we're looking now for a cluster scheduler that's written in Go, um, that kind of brings us down to two choices. We have HashiCorp Nomad, and we have Kubernetes. The other major requirement that we had was to be able to run literally everything on one platform. And this really involved needing to reduce the maintenance overhead of whatever solution we ultimately selected. To that end, we looked at running Nomad as our preferred solution. I'm aware of many teams that run Kubernetes and do incredible things with it, but they're also staffed with more people than my team. And I've heard horror stories about what happens when it doesn't go well. To date, we've only had one major Nomad outage, and we attribute this to the simplicity and elegance of which the Nomad solution is implemented. It's something that my team maintains with relative ease. So when I mention that we run the HashiStack, my team runs the entire run layer of the HashiCorp suite. We run Nomad, Consul, and Vault. We do so with 3 engineers, all of whom are fractional. For attendees who are outside of the interesting world of the Bay Area, that means that none of us have this as our full-time job. We do this in addition to maintaining other systems, consulting on other projects, and generally handling whatever comes up at the time. We run all of our software on Alpine Linux, not only in our containers, but also on our servers. This means that we develop our own custom packages for the operating system, and that's how we handle our updates. We do deploys, application management, and some troubleshooting as a self-service option exposed to our product development team. There are some tasks, though, that of course we would like them to come talk to my team, which handles the cluster itself. Tasks like that usually relate to any kind of recovery or outage mitigation. The last bullet point doesn't make a whole lot of sense at this slide, but trust me, it will by the end of this talk. We decouple all of our updates to the platform through a layer cake of isolation. In fact, most of our developers aren't even aware when we're performing server updates because it's entirely transparent to every application running in the cluster. Now, this talk is about Nomad, but I do think it's important to briefly talk about Consul and Vault, because they really are some of the hidden value adds to Nomad. Consul provides us a unified service discovery layer where services that are aware of the Consul API are able to transparently learn where other services are within the cluster. Now, PHP is not necessarily Consul aware, so this is where Consul's party trick of being a DNS server comes in. We can ask our local DNS servers for the cluster where specific names are, and they will be resolved via the Consul service catalog to wherever that Nomad job happens to be running at the time. This is really a powerful thing to no longer worry about where your applications are running. We also use Consul for automatic clustering of Nomad, such that when we add or remove servers, they transparently join the fleet. Our load balancers directly integrate with Consul. This helps us serve only healthy application instances to outside users. And finally, we use Consul's key value store for basic distributed state. Most importantly, it forms the backing store for our Vault cluster. Vault, if you're not aware, is a secret store and authentication platform that integrates well with the HashiCorp suite. We use it to protect our secret configuration data, things like API keys or private keys to push servers. It also serves as our authentication nexus with Okta. Yesterday, during the Nomad office hours, there was a question about single sign-on with various providers for Nomad. Well, you can get very close to single sign-on using Vault. It provides you a single point where you log in, and then you can request tokens for any other HashiCorp service. We also use it in a much more transparent role, something that even my team sometimes forget is happening. Anytime anyone in our organization asks for secret data or controlled access to a subsystem, that request is logged by Vault. Now, we could store these logs locally, but in order to ensure that they have an optimal level of immutability, we actually engage a third-party security vendor and we send our Vault audit logs to them. That way, there's no question. What's in the log is what happened. And this allows us to very easily go back, and if there's ever an interesting event, we can say, well, what happened around that? Who authenticated when? Who was talking to what service? Fortunately, we've never needed to use this capability, but it certainly lets me sleep easier at night knowing it's there. So now we can look at some of our stack by the numbers. In this slide, I'm only going to talk about BetterHelp's primary serving cluster. As Nomad is our unit of engagement with the data center, we have several smaller clusters, but only one large one that serves user traffic. This cluster has between 40 and 80 hosts at any given time. It's scaled dynamically based on load. Regardless of how many hosts we're running, we tend to have about 500 resident tasks that serve anything from user-facing traffic to our Prometheus-based monitoring stack to random small projects that people just need to run somewhere. As I mentioned earlier, we use PHP. Now, one of the fun things about PHP is that it has absolutely no async capability built in. There are various ways that you can fake this capability, and you can get something that looks like async, but the only way to truly get it is to launch your tasks external to the FPM process manager. We use Nomad to handle over 2,000 batch task launches per hour. This allows us to get true async, which happens on our schedule whenever we need it to happen. We can also use Nomad to force launch certain tasks if necessary. We also use another kind of batch task. We increasingly use parameterized batch tasks, which allow us to handle certain events that we don't want to put on a serving thread. We want the user interface to remain responsive, but we also want this slow task to happen in the background. So there are several points within our platform where if you click a button, it will fire off a Nomad dispatch event and a task will spool up somewhere in the cluster. Now, the fun numbers that I like to use are when we switched over to this platform. We saw an almost immediate 60% reduction in raw computing cost, and this allowed us to redistribute that to more specialized services. We were able to use a database as a service product within Amazon Web Services to dramatically reduce our overhead for persistent storage. The other fun number I like to use is how fast we're pushing to this cluster. On average, every workday hour, there are 4 application deploys. Sometimes there are many, many more, to the point that we've had to start batching them and say that you have to wait for a released train to depart the station. Now, all of these are very interesting numbers, and you might wonder, how large is my team? How long did it take us to get here? Is this something that you could duplicate? From start to finish, initial proof of concept to the day we cut over production traffic took 7 months. And during that time, I was the only engineer who was working on this project full time. So this is very much attainable for a small shop. You can have a system that works just like this, and you can reap the benefits from it. It definitely takes some investment from management to understand that you won't have a whole lot to show for it for the first couple of weeks, but you can get there very quickly. So once we had the Nomad system available, we no longer had to handle the day-to-day business of really babysitting the fleet. And that freed us up to do cool stuff. And cool stuff is what I love to do. It's where we take, the resources that are available and then turn it into something truly impressive. One of the cool things that we do it doesn't sound cool at the surface, but we run everything on Docker on Nomad. There is not even a single task anywhere in our production fleet that is not running in a container that Nomad is aware of. And this lets us leverage Nomad fully to do rolling updates, blue-green deployments, canary rollouts, you name it. As I mentioned earlier, we also run all of our async tasks on Nomad. There are no exceptions to this rule. So this allows us to shed batch workload if we need to during an incident, or if we just experience a traffic spike. We can say that batch workload is running at a lower priority, and we simply won't schedule that for a while. We also use automatic security scanning for all of our Docker containers. This is a 0 configuration item, and so when a task is launched into the cluster, within 12 hours, security scan results will be available. We run this on a slightly slower pace just to avoid hammering an upstream vulnerability server. As I mentioned, we also run Alpine Linux everywhere. Alpine Linux is quite popular inside of containers, but not many people realize that it is a full-fledged Linux distribution that you can run on your servers as well. Running only one distro allowed us to amortize effort. And finally, We're realizing the Phoenix server model over the next 2 quarters. We're migrating to a fully immutable infrastructure where not only do our applications run in immutable systems, and to deploy a change to the application, you must deploy a new build. We're doing this with our server operating system images as well. So the automatic security scan is based on a tool suite that we've released called the Yurt Tools. This is open source. You can deploy it in your Nomad cluster and get this same screen with your tasks. It provides automatic security scanning for Docker containers. It provides us a sanity check when things are out of date, and it allows us to get checks for things that we don't build. For our own code, we run many of these checks at CI time, and we'll block a build if they fail. But for third-party services that we're pulling off the shelf, we need to pull those from, we need some other way to monitor those, and this provides us a way to do that. It also is one of those fantastic tools that we didn't realize when we wrote it, but when you bring this up in a meeting of security folks, they become very happy that this information is all in one place now. We run Alpine Linux everywhere. For those who are not aware, Alpine is a very small Linux distribution. They're focused on security, they are focused on correctness, and they are focused on minimalism. They use the OpenRC init system, and they use the Muscle C library. This allows us to ignore large swaths of vulnerability disclosures as they simply don't apply to our platform. Many vulnerabilities are predicated on the idea that you are running a quote unquote standard Linux distribution, and they make assumptions based on that. Since we run something that's a little bit off the beaten path, we're able to not leverage security by obscurity, but leverage security by minimalism. You can't attack what isn't there. This also meant that we didn't need to build tooling for multiple distributions, since we were already using Alpine for our Docker containers. It just made sense that based on that previous investment, we would use Alpine for the servers as well. Now, this is the interesting thing. This is what I'm truly excited about in the work that my organization has done with Nomad. We are realizing the Phoenix server model, where when a machine has a problem, we don't troubleshoot it. We shut it down and get a new one. The metaphor I like to use here is layers of immutable cake. The small cakes represent individual tasks. You can see them, you can look at them, but unless you're authorized to remove the plastic cover, you can't interact with the cake in a destructive fashion or in a way that would mutate its state. This is fairly well understood, and this is something that many people who use Nomad today are very well versed in. You build your Docker container, you ship it to the cluster, and it's static until you ship a new version. What we're now moving towards is the larger cake underneath. The large cake represents the actual server, which is hosting Nomad. Now, we build on top of a piece of technology called Linux Kit. It does a build based on OCI containers and Docker image files, and allows us to assemble an operating system that is purpose-built. Packer is a fantastic piece of technology, but it's predicated on the idea of self-hosting operating systems, and that's not required for the use case that we're pursuing. We're pursuing the use case where when you need to upgrade the OS image, you reboot the machine. Or even better, since we run on cloud, you simply add new machines and age out the old ones. This also allows us to be much, much more confident when we update various components of our stack. It allows us to say that we can do a blue-green deployment of the entire production image. This is something that saved us more than once from a rather embarrassing outage. So that's all I have for you today. If you'd like to know more, our Immutable stack is completely open source. You can deploy it yourself and run on the same technology that we do. More information can be found at www.resinstack.io. As I mentioned, our Automagic security scanner is open source and lives under my namespace on GitHub. Feel free to check it out. And of course, if you'd like to know more about BetterHelp, you can find that out at www.betterhelp.com/about. And if you're interested in solving interesting problems like those you've heard about today, we're always hiring driven people. Thank you. I'll be available to take questions during the panel section.
Right. Thank you so much, Michael. That's super interesting stack that you're running on.